In this lesson, we're going to talk about and learn about geometric sequences. A geometric sequence is a sequence of values that follows a pattern of multiplying a fixed amount times each term to arrive at the following term. So for instance, if I am given these values 2, 10, 50, 250, there's a pattern. How do we get from 2 to 10, 10 to 50, 50 to 250, and so on and so forth? And if we look at this, sometimes we can see right away that to get from 2 to 10, you would multiply by 5. But that multiply by 5 has to work for each item after that. So for each value that follows, we're going to need to say, okay, how do we get from 10 to 50? Well, that we would multiply by 5 as well. And then 50 to 250, we would also multiply by 5 to get from 50 to 250. So the pattern is multiplying by 5. That multiply by 5 is the value that we're multiplying. It's a fixed amount because the 5 never changes, and that is called a common ratio. So the common ratio is an R value, and that R value is equal to 5. So we're going to practice finding that common ratio. How do we get from 3 to 12, 12 to 48, 48 to 192? Well, sometimes you can see what you multiply to get from 3 to 12, and sometimes you can't. So I'm going to pretend that I don't know what number we multiply by to get from 3 to 12. So I'm going to take 12 divided by 3, and I'm going to go backwards. 12 divided by 3 is 4. So that means I multiply by 4. Show this down here because I have more room. I'm going to multiply by 4 to get from 3 to 12. Then I don't know if 12 times 4 is 48, so I'm going to take 48 divided by 12. Maybe I'm using my calculator. 48 divided by 12, I get 4 again. 12 to 48 would also be multiplying by 4. Then I'm going to take 192 and I'm going to divide it by 48. When I take 192 and divide by 48, I get 4. So 48 times 4 is 192. Therefore, the common ratio is 4. Now, if the first one is 4, the second one is 4, but the third one is something different, then there is no common ratio. They all have to be multiplying by the same amount. How do we get from 80 to 20 to 5 to 5/4? Well, I'm going to take 20 divided by 80. In my calculator, it might tell me 0.25. I'm going to change that to a fraction, and I get 1/4. I multiply by 1/4. 5 divided by 20, I put that in my calculator. Or maybe I do this by hand. That is also 1/4. 5/4 divided by 5. If I need to use my calculator, I will. However, I can also divide off to the side. 5/4 divided by 5 is the same thing as 5/4 times 1/5. 5 over 5 is 1. That is also 1/4. This has a common ratio of 1/4. So sometimes your common ratio is a whole number. Sometimes it's a fraction. Sometimes it's positive and sometimes it's negative. Let's try a few more. 750 to 150 to 30 to 6. Let's see what that is. And I'm going to have you try these 3. So if you need to press pause, you should use your calculator, and then we'll come back and check your answers. Okay, welcome back. You should have work on your paper. You should have 150 divided by 750 is 1/5. You should have 30 divided by 150 is 1/5. And you should have 6 divided by 30, which is also 1/5. Therefore, the common ratio is 1/5. On the next one, to get from -3 to -6, we multiply by 2. multiply by 2 to get to the next term of negative 12, multiply by negative 2, by positive 2, positive 2, positive 2, positive 2, multiply by positive 2, positive 2, positive 2. Negative 3 times a positive is negative, negative times a positive is negative, negative times a positive is negative. So that common ratio is 2. And then we'll do the same thing on E. You should show 6 over 4 is going to be 3/2. 9 over 6 is also 3/2. And then 13.5 divided by 9, if you put that into your calculator and make it a fraction, you would have also gotten 3/2. Therefore, the common ratio is 3 over 2. So there's our 3 answers. Okay, now we're going to practice that by finding the next 3 terms of the sequence. So you'll find your common ratio and then find the next 3 terms in the sequence. How do I get from 2 to negative 6? I'm going to multiply by a negative 3. How do I get from negative 6 to positive 18? I multiply by negative 3. 18 times negative 3 is negative 54, so the common ratio is negative 3. So if I want to get to the next term, I would have 54 times negative 3. If I multiply that out, I get negative 162. So negative 162 will be the next term in the sequence. Then I'm going to take that and multiply by negative 3. That gives us positive 486. Then we multiply by negative 3 again. And I get negative 1,458. So those are the next 3 terms in that sequence. So our first step was to find the common ratio. And then the second step was to use it to find the next terms. Okay, we're going to have you try B and C. So press pause and then come back and check your answers. Okay, the next 3 terms for B, multiplying by 3 would give us 81, 243, and 729. That common ratio was 3. And then here our common ratio is 2. So you should have gotten 17.6, 35.2, and 70.4. Okay, the last problem in this video that we're going to talk about before we get to the next video will just be able to recognizing whether or not a sequence is arithmetic or geometric. So remember, when you have an arithmetic sequence, you have a common difference. And that common difference is what you add to get from one term to the next. Sometimes you add a positive number and sometimes you add a negative number. And then, of course, the geometric sequence is when you have a common ratio, and that's the value that you multiply to get from one term to the next. So we look at this first example and we say, how do we get from negative 7 to negative 5, and then negative 5 to negative 3, negative 3 to negative 1, and is there a pattern? Sometimes it's very clear. In this case, we can see that to get from negative 7 to negative 5, we're going to add 2. Then we're going to add 2 to get to the next term. we're going to continue to add 2 to get from one term to the next. When you add a common number to get from one term to the next, that's a common difference, and therefore that would make that an arithmetic sequence. So we're going to back up our answer of arithmetic with the actual common difference. Okay, the next, how do we get from 56 to 28, and then 28 to 14, and then 14 to 7? Well, to get from 14 to 7, if you're going to be adding, you're going to be adding a -7. But that's certainly not how you get from 56 to 28. You don't subtract 7, subtract 7, subtract 7. So that would not be a common difference. So now we're looking at what would we multiply to get from 56 to 28. So remember what we did earlier. We said, maybe if we take one term divided by the previous term, we'll be able to see what that common ratio is. And indeed, how we get from 56 to 28 is by multiplying by 1/2. Multiplying by 1/2, multiplying by 1/2. So our common ratio is 1/2, which makes this a geometric sequence. Okay, you try the next 3. Press pause, and then come back and we'll check your answers. In case you didn't press pause, I'm giving you a little extra time to do that. Okay, on C, I got a common difference of 2, which makes this arithmetic. On D, we got a common difference of 2, which makes this arithmetic. And then on our last try, we got a common ratio of 2, which makes this geometric. And as you know, with the arithmetic, there's formulas that allow us to find a certain term in our sequence. It allows us to find the sum of a certain number of terms. We're going to be doing all of those things with the geometric sequences as well. And we will do that, or begin to do that, in the next video.